In this question, we're being asked to conduct a goodness of fit hypothesis test, but we are given what the expected proportions are for each category. So, for example, out of these categories A, B, C, and D, the proportion of them that we expect that our null hypothesis says should be proportion of A should be 0.3, proportion of B should be 0.2, proportion of C should be 0.3, and proportion of D should be 0.2. And what we're given in this observed column is what actually happened. So what we want to know is how many of these there are, how many observations there were in total, and then the expected frequency will be the proportion that we expected times the total number of observed values. So one way to do that is in a calculator just to add these up, multiply it times 0.3, then multiply the added number to 0.2, multiply it to 0.3 and 0.2 and get it. I like to put this all in a spreadsheet, which will come in handy as you'll see. So I'm going to do that now. Okay, now I know that my sum, here let's sort these so that they get rid of the gaps. Now I'm going to find the total by adding these together. So there's 142. Now I'm going to say I want this total times the 0.3, which was the expected proportion for category A. Now I'm going to do a little spreadsheet trick. I'm going to come over here and I'm going to put dollar signs in front of the B and the 6. The dollar signs make it so that when I drag this down, that this sum 142 stays in place. In other words, normally if you didn't have the dollar signs, the next one as I drag this down would say, all right, I want this to be whatever's in B7 times 0.3 and then B8 times 0.3. Now there's another problem I'll have to deal with. That is, they're all 0.3 right now. So notice, if I drag it down, they're all going to be the same because they all are B6 with those dollar signs in front times 0.3. Now I don't want that. I want the rest of these, 0.2, 0.3, and 0.2, to be the proportions. So for B, it was 0.2. I'm going to change that to 0.2. For C, it was 0.3, so I'll leave that one alone. And then for D, it was 0.2 again. Another quick tip, the way I added those dollar signs, you can just hit the F4 button and it'll put those dollar signs in. But then dragging doesn't change the cell that's being referenced. Okay, now what I need, I could do an O minus E column and then an O minus E squared column. But I think what I'll do is do it all in one fell swoop. So this is going to be my O minus E squared divided by E column. So this is also called the residuals in some cases. So all I have to do here is look at the, I'm going to click the O column, the O observed column, minus the value in the expected, the E column. Then I'm going to square it, and then I'm going to divide by the value in the E column. And now here, I can just drag down and it'll change that for each row. So now it's going to calculate that same calculation for each row. And what I want for my test statistic is the sum of D2 to D5. Okay, so let's go back and fill in what we know now. The expected frequencies are given to me in this spreadsheet. So I've got 42.6, 28.4, 42.6, and 28.4. Now by adding up this last column, I've got my test statistic as well. So let me use maybe 12.155. And now I need the p-value. So I can use the equal chi square dot dist dot rt to confirm that it's a right tail test. And I'll click on that test statistic. And the degrees of freedom, that is the number of categories I have minus 1. So you can see I have 4 categories, minus 1 will be degrees of freedom of 3. The other formula that's common in spreadsheets, and it works in Google Sheets here too, is just the chi dist formula. And again, I would give it the test statistic and the degrees of freedom, and it'll give me the same answer. Okay, so let's use, how about 0.0069 for our answer for the p-value. Now this is a very low p-value. It's much smaller than the alpha, the significance level. So I'm going to reject the null hypothesis. And then cross your fingers, lots of green.